Good morning. Let's get started. Welcome. My name is Brian Bowman. I'm a director or architect for Archwell Essentials. And today we're here to talk about real-world monitoring for PASOE or Progress App Server for OpenEdge. If you're in the wrong place, that's okay. You can change now. As we go through this, if you have questions, please raise your hand. I'll answer questions throughout the whole thing. Got a lot of material, a lot of details to go through, so I'm just going to try and get through it for you. I'm around all week. If you have any questions, I would love to hear your experiences in dealing with PASOE and what you've experienced. As it says, this is real world. This is what I'm doing or what we're doing at Archwell Essentials. I'll talk a little bit about what Archwell Essentials is and where we fit into the Progress world. You probably have not heard of us. A little bit about me. I've got over 30 years of Progress experience. A vast majority of it is working for Progress. With Progress, I started in tech support, and effectively I've done everything except for legal and accounting. So I was in services, I was in consulting, I was in tech support, I was a product manager for 7 years, for the database, working with my colleague next door, Rob Strait, who's the director now. A lot of different things with Progress. I had the luxury of learning about Progress and about the database from most of the guys who developed it and wrote it. People you know and talk about and talk to. Mike Fergal, Gus, Guy Washburn. Anybody who originally worked with the database, worked with Rich Bandel a lot. I've also learned from Paul Cavallis and Tom Bascom a lot, and Adam Backman about the database. Adam was actually the second employee I met at Progress Software. So a lot of experience with that in terms of understanding the database and the environment. My focus really is on disaster recovery and business continuity. That's where I'd love to talk for the most part. But I've learned a lot about Progress throughout history. And just a side note, if you ever want to talk about barbecue, American barbecue, I'm an addict to it. So I'm in the process of meat recovery. From this previous weekend, I did a competition in northern Vermont. So you have to bear with me as I go slow through that. So anyway, happy to talk about that anytime as well. A little bit about Archwell Essentials. We are a managed service provider, very young started. We provide all different types of services, focusing on the financial industry. From an OpenEdge standpoint, we have one customer. It's a major, one of the top 5 mortgage industry banks in the United States. Mortgage industries in the United States. They requested to remain anonymous, so I won't leave it at that. But they're our major customer. Typically, that's what we do in terms of supporting them. We'll talk a little bit about the application in terms of, so you understand where we're coming from an application standpoint. They've run OpenEdge since it was Progress, long time, since version 6. We just migrated about a year ago to 12.2, as well as migrated to, obviously, to PASOE, so we can talk about that as well. So that's a little bit about Archwell Essentials, the company. From our team standpoint, from a DBA standpoint, collectively, we have about 158 years of DBA knowledge. And this is not an application developer who is doing DBA work. We are DBAs that have been DBAs for that long. So there's 5 people on my team, and I have 2 offshore, so we support 24/7 for our environment. So a lot of knowledge in our team. From an Archwell Essentials standpoint, we support the whole infrastructure environment, including networking, Linux, and telephony. Within OpenEdge, we have in the range of 100 plus AWS database, AWS servers. So that gives you a little bit of an idea of what our architecture looks like from a database standpoint. We did have, as I talked about, us doing migration. We migrated about 3.5 years ago from AIX to AWS. So we're all 100% Linux, AWS. And we have migrated within the last 2 years from the classic app server to PASOE in 11.7 and go from 11.7 to 12.2. So I have a presentation later on in the week or today, I don't remember which one it was, on staying current with OpenEdge. And we talked about that specific topic of migrating or making sure you stay current in your OpenEdge and how we do it. Important for me to help you understand and remember that I'm talking real world. I was a product manager, I worked for Progress, but that's not what I'm going to talk about today. I'm talking about what we do and why we're doing what we do from a monitoring of PASOE standpoint. It was a challenge for us, believe me. All right, so let's talk a little bit about our PASOE environment. We have two applications. Both of the applications are controlled through access through an ALB and an application load balancer. There's actually a network load balancer before that, but that's in the whole AWS configuration and world. And my expertise is I can spell AWS just barely, and I know how to get the UI to work, but that's it. So anyway, there is access through the ALB to PASOE for almost every request. There are a few that go local, that go direct, but very, very few for us, from our standpoint. And I'll show you some numbers in a little bit as for the type of queries that we do. We have 4 remote PASOE servers. We have 2 instances set up on each server, so that's 8 servers. Of those 2 instances on my remote PASOE servers, 1 is a read-write and 1 is a read-only. Architecturally, my architects decided that that's the way they wanted to break it up. So 1 connects to the source database and 1 connects to the target database. So we can offload queries only, if you're only querying the database, we can offload that to a read-only PASOE instance, which goes against our REPL database. So it offloads that work across both of them. We also have 2 instances running on our database server. We would like to get everything off the database server, but we have a certain amount of queries or requests that have to run on the database because they are very heavily weighted, a lot of data I/O, and they take a long time to run. So we have to run them as fast as possible. When we originally architected this, we made those local loopback clients. Because the other thing we're trying to do is get everybody out of the database from a shared memory or direct connect model. So they're local loopback, local to the database. From a performance standpoint, we did a bunch of benchmarking, and we saw that if shared memory connection is 1, then a local loopback is 2 to 3 times slower than a direct connect. A remote connection is 10 to 12 times slower. So that's kind of the metrics that we weigh in terms of determining what runs on the database PASOE versus what runs on the remote PASOE.
So that's kind of that architecture. Those 2 instances on the database, they are exactly the same, but they're there for redundancy. So that we can take one offline and the application is not affected, doesn't cause a problem for the application. So it's important to understand that even though they're on the same machine, that's a single point of failure, but we can take one offline if we need to tune it, we need to change configuration, or we have issues, which we do tend to every once in a while have issues. So that's part of what we did to solve that. Our second application is much easier. There's 6 remote PASOE servers. Each server has 1 instance on it, and that's really pretty straightforward. You'll also notice, important on our first application, it's an APSV and web methodology or architecture. Our second one is REST-based architecture. Important to understand when it comes to monitoring and what data you can get at from both of them. So that's one of the things that we learned is we thought, oh, when we go gather data, we'll gather the same data set for every type of connection methodology. Doesn't work that way. We'll see that a little bit. So just understand, the reason they're 2 different things, 2 different architects designed them from the application standpoint. So. Okay, before I go into this, how many people are running PASOE today? I need to understand, okay. Of those of you who are running PASOE, how many are running 11.7? Okay, cool. How many are running 12.8? Oh, quite a few. I'd like to hear from you. We started with 11, so to back up a page. In this environment, on the application 2, we started with 11.7 and then migrated PASOE to 12.2. On the application 1, we started with 12.2. I wish with application 2 we would have started with 12.2 because it's just a world of difference. We found a world of difference between the two. So without monitoring, it's really important to monitor. It's hard to understand and debug application challenges when they call you and tell you you have a problem. Good luck trying to figure out what that problem is if you don't have any debugging, any monitoring on. They call you and tell you it's slower. How do you know whether it's slower? It's hard to figure that out. So tuning, supporting the business. And despite what others say, PASOE is not your classic app server. You know, you can take your application and move it to PASOE from a classic app server and run it. But from our experience, you'll run into a lot of challenges, a lot of opportunities for improvement. So it's important to understand that. And you'll continue to run through it. We've been running on PASOE for 2.5 years. We're still coming across application challenges that are cropping up with us today. So that being said, would we do it again? Absolutely. And so many pros versus cons to it. It's just to help you understand that. So let's take a look at, I'm going to go in and talk about quite a few different tools that we're going to cover with this, and what those tools are like, and just give you a smattering of examples of those tools. Then we'll talk about what do we do, and I'll show you what it looks like from our perspective. So in terms of tools, we have Open Edge Management. These are some screen captures from Open Edge Management. It's relatively straightforward, gives you base level information. We don't use this very much, I'll be honest with you, but these are real world pictures from our environment. So you can see CPU, you can see connections, you can see memory utilization, which is what a lot of people are worried about. And you can see our memory utilization, our CPU grows or spikes in there in the middle as well. So from a memory utilization, one thing to understand about our environment, we have the luxury that we can shut down every night and restart our whole environment. So the reason that's a luxury is because we can shut down PASOE and restart it. So there's a lot of people that talk about having memory leaks and memory problems. We really have never experienced that, and I think it's because we have that ability to shut down and restart every night. And we're very distributed across multiple requests in multiple instances. We have other challenges. We have CPU challenges, but that's a different discussion. That's a tuning discussion. So anyway, this is an example of what Open Edge Management looks like from a reporting standpoint in terms of visibility. Some other graphs from Open Edge Management. They're okay, but they don't really help you a whole lot in terms of understanding if there's a real problem going on right now. And that's whenever it comes from a DBA standpoint, do I have a problem right now? What am I looking at right now in terms of what I'm working from? So that's an example of what Open Edge Management looks like. As you start working in the PASOE world, you're going to become very familiar with tools, with REST, requests, JSON, JMX. You really, if you want to dig in and understand the details, you don't have much choice. One of those tools that's actually really easy and really helpful to understand and learn about it is Swagger. How many people have used Swagger? Okay, about half of you. So Swagger is an industry tool, and it gives you effectively, it's a browser interface into REST requests. I guess that's the best way that I can state it. So it gives me the ability to go out and say, I can actually delete applications, I can stop the application, start PASOE from here. We've never done that. I'll be honest with you, we stay away from that as far as we can. If I could disable it from the Swagger screen so my DBAs can't get to it, I would do that. But you can use it to get access and to see what the data looks like, so you know what to go build your environment look like. So this is an example of what PASOE management APIs look like through Swagger. And you'll learn things like, what's a session? What's a session ID? What's a web app? What's an application? You'll have to understand the differences between all those when you start working with Swagger and how it's architected. So this is what an example of Swagger looks like. This is really looking for web metrics. You can see I have an app name of FMLS API and a web app name of FMLS API, all in uppercase, or the first one's in uppercase. From an architecture standpoint, it's a little hard to understand why they're both named the same. It's what they decided to call them that way. But anyway, so then when I go run it, this is the type of data I get out of it. Now, the data in the important things to understand, the red 200 tells me I'm successful. So you'll learn what 200 and 500 is. 500 is basically an error, a browser error, right? Data invalid return data, bad request, something like that. In our environment, that's a challenge for us because if I request something, and remember we support a mortgage company, right? If I request something and I put in a bad loan number, well, PASOE and the underlying Tomcat infrastructure think that's an invalid request. So I get a 500 error back if somebody fat fingers request a loan number and request data on a loan number, on a bad loan number. So it's hard to differentiate between that and what's a legitimate 500 in that the application's not available. And that's part of the challenge that we see and we work with a lot. Now, you can, within the application, trap for that, right, and do work for that. There's also, from what I read in 12.8, the ability to lessen the application more, the infrastructure of the setup, the configuration. So those errors like that don't show up as 500, they show up as another number. So it makes it a lot better from a debugging and a management standpoint. So anyway, but the important things to understand here is this gives you an example of what a curl command would look like. And curl is a command line tool in the Linux world, in the Unix world, to be able to go out and run a query, make a request for a browser request, and get the data back. And that data back can come back in HTML, it can come back in JSON, whatever it comes back in. But this shows you what the actual command that it sent was. So you can go copy and paste that. Now you have the basis for building your monitoring tools if you want to do it from the command line by yourself. And it also shows you what the request would look like from a browser. So I could take that request, go put it in a browser, and I get the data back just the way it shows. And it shows me all the data and it's in JSON format. So you can go out and parse it from a JSON format standpoint. So that's an example of Swagger. It's one of the tools that we use. We found it probably the most useful tool in terms of understanding the infrastructure and being able to get details back in real time and understand how it's working. Another tool that Progress Consulting developed quite some time ago was a tool called Iceberg. And Iceberg is an open source tool. It's a tool that's available in GitHub for you to download. Progress, I believe, has since started supporting it and done a lot more development with it. We have the earlier version of it. And it's basically using the ABL to call the REST APIs to gather a bunch of data and return it. So you get all the source code, so if you want to go look at the source code for Iceberg, you can do that as well in terms of debugging and understanding it. So anyway, we use Iceberg because it's an easier thing for us to go run and be able to do screen scraping out of it and pull out some stuff that I couldn't figure out how to get other places. So I'll show you another example of that in a minute. But these are what screens look like from the Iceberg standpoint, from a tool standpoint. A couple of interesting things that help you understand this. This section down here on the bottom middle shows the agent's PID. So that is one agent and the sessions that are in there for that agent. It can help you. It's a really easy way to be able to see this. We'll talk about agent details a little bit later, and I have a better way to show you how to get to that. But this is one way to get to that type of detail. The other part that it shows you all the details of every session, and whether it's active, reserved, in use, and any details that follow through with it. So that's another advantage that Iceberg brings to the table and gives you from that detail standpoint. Another tool we use a lot is ProTop RT. And we use it for the database, but we also use it for PASOE because it gives us a really good view. The bottom section is all the PASOE information. It gives us a really good view of all the details at a quick view of what PASOE is looking like across all the servers. You can see I have all my different servers listed over there. LXO1, PAS Liquid 1, PAS Liquid 2, LXO2, 3, 4 servers. And so it shows me their status. It also shows me how much memory they're using from a visibility standpoint. And again, now I can go see that I have one PASOE instance in this example. It's using a lot more memory than everybody else. So I need to go understand what's happening with that guy. So that's another tool that we use. The ProTop dashboard gives you some information as well. This is a browser-based solution, and it shows you, connections, memory usage. There's other things that it shows you. These are generally two that people tend to focus on the most. Certainly on the connection side, that's what we deal with in terms of what are the connections, how many of those connections are actively doing work. Because if you run out of active connections, trust me, it hurts. And we've done that. So we run into problems with that. So anyway, ProTop Dashboard is absolutely another tool that will work for you in terms of providing that information. I talked a little bit about REST or OEMX. OEJMX is just a JMX extension, really, to be able to access the data. There are kind of two different ways to two different tools to access kind of the same data from the same location. They're both from the command line. OEJMX can be used as well. One of the important things to notice is that for us, OEJMX seemed to work really reasonable in 11.7. Remember, I started one environment in 11.7, so I went, and that was our first environment we did. So I went and wrote all my scripts for 11.7 to capture the data, to gather the data. And then we moved to 12.2, and all those scripts stopped working because the OEJMX interface changed. So that was a challenge for me. So that's when I started going, okay, let's go use REST, let's go use curl, and you go that methodology to capture all the data instead. And so we've slowly but surely migrated away from OEJMX. One of the other things in terms of talking to Progress about this that we learned was there's a big performance difference between the curl, the REST API, and the OEJMX. In the scale of, if I make a REST request for web statistics, it may take 200 milliseconds to complete. If I make the same request for OEJMX, it can take 3 seconds, 5 seconds, 3,000 to 5,000 milliseconds to complete. So there was a big difference. And I didn't believe it until I talked to them, and then I went and found my two queries that were the same and ran them, and sure enough, that's exactly what I saw. So, and you think, oh, that's not a big deal, until I have to query 8 servers in theory at the same time to capture the same set of data. So that's how it works. That's what's important from that perspective. Important thing to understand. But you'll learn a lot more about REST and OEJMX as you start working with it. So part of the reason that we chose, well, actually, I'm getting ahead of myself. I'll jump into that in a minute. There are tons of third-party tools you can take your data and put it into and graph. One that is our corporate standard is a tool called Sumo. Whether I don't endorse Sumo one way or the other, it has some really cool features to it, and it has some challenges. But overall, it's a pretty good tool. This is what my data looks like in Sumo. In Sumo, I can go graph the data, I go capture the data, and then I graph it in Sumo. I wanted to give you an example of a third-party tool, which is not in the Progress environment very much, that might help you understand how things work and give you an idea of what it looks like. And you can see the top graph is really the busy count, shows me at the sample time how many of my multi-session agents are busy, actively doing work. And then the bottom one is kind of the same thing over a longer period of time. And you can see at one point in time we had a spike between August 12th and 13th. And our limit of number of active sessions is in the range of 55 to 56. So when we hit 40, we panic. Well, we don't panic, but we know it's something to be aware of. So. A different look at from a Sumo standpoint. One of the things I'll talk about a little bit later is a round trip round trip response time. This shows me my response time to the database. What we developed was a round trip query that does a reasonable query. And so we run that query every single time we sample. And it tells me from the time I submit the query to going through PASOE to make the request to the database to return to PASOE back to me, that's how long it took. So that gives me a baseline to say, okay, I expect my response time to be 1 second for this. If it's 3 seconds, if it's 10 seconds, I have a problem somewhere. So it's a good bellwether for us to understand how that works. The other part of that is this load balancer is this big black box to me. So I can run the same query. The top one is directly to the PASOE instance. The bottom one is through the load balancer. So then now I know if my load balancer is a problem. And what will Amazon say if we call them and tell them we have a load balancer problem? They'll say it's not us. So, and that's okay, that's fair enough. The other interesting thing is you can see periodically, these are the same time frames. Every once in a while, you'll see where the load balancer's response is longer and the database isn't, and the database direct response is. So it tells you there's something weird every once in a while going on with the load balancer. Not a problem to really worry about because it works okay for us. You know, there's not major problems there. So anyway, that's an example of what Sumo looks like in terms of access. Here's the last screen I'll show you from Sumo. You'll see in this request, we're seeing, this is one of my easier PASOE instances. Oh, this is a very specific response, a very specific API. We see that we had 255K requests to this API, right? And you can see day in, day out, and then the 24th and 25th, it goes blank. That's because that's a weekend, and we don't capture and manage data on the weekends. So in our graphs, these all look like this. Now, the interesting thing here is, you can also see that I have service, all of a sudden I start getting service errors on August 26th. Well, guess what they did on at 11 p.m. on August 25th? They did a code change. Mr. Kafalis is the winner. They did a code change, and it effectively broke 70% of this request's responses. So telltale sign, oh, look, I have a problem. Is it me? No, well, it's the application, so we gotta go figure that out. So anyway, so that's part of what this type of a graph gives you, this type of utility gives you. Now, this is weird because these screens are data that I gather. This screen is actually Sumo parsing the app server logs and counting up information out of the logs. So that's one of the big powers of the Sumo tool, is that it is really a glorified log parser and manager. But it gives you counts like this, which are really helpful, and it's really fast. So anyway, so that's an example. Sumo is our corporate tool, so we have to use Sumo. And that's okay, because it does a whole bunch of other things across the enterprise. So, okay, so let's talk a little bit about what we do and why we chose to do what we do. Our data capture is 100% script driven. So I showed you OE management screens, I showed you ProTop RT screens, I showed you ProTop screens. We don't use any of that in our data capture, in our metrics, in our reporting to understand the details. For pulling the data, I've talked about this, we use curl JQ, which is really a JSON parser from the command line that gives us the ability to go parse that JSON. And then we screen scrape from Iceberg. I talked about OEJMX, so we already talked about that. By default, we go out and poll every 5 minutes. We recognize that it could be a performance hit on the system if we polled more often. I'd love to have 2-minute polls, but it does do a significant amount of I/O and work as it's doing the polling. So the other thing that we do every single time we poll is we do what we call a health check. We have the ability, we have the tools to be able to go run 10 different alerts, 10 different rules against the last line of data that we gathered, and do a health check against that to say, are the number of active sessions more than 50% of my available sessions, more than 70%, more than 80%? Alert, alert our digital operations center and alert us the DBAs, that something's up and something's not right. Things like that. We also look for performance metrics. Is my DB response time over 3 seconds, over 5 seconds, over 10 seconds? You know, that type of stuff. So we do that health check every single time we do that. So part of what you're thinking is, you know, there's a lot of scripting here, a lot of details. One of the things that whenever this gets posted on the PUG Challenge website is I will give you sample scripts of all the scripts that we use. All our polling scripts, all our health check scripts, and we'll go into details on some status scripts as well. And you'll get examples of those that run in my environment. So you don't have to go start from scratch, because that's what we did. We started from scratch. When we started with PASOE, we could spell it. And then we started learning from there. So I wanted to be able to help with from that perspective. From a data standpoint, this is what my polling data looks like. Really cool, really helpful, huh? Not really. A lot of details, a lot of data. There's also a lot of zeros in there. That's probably not good. So by default, this is polling a web request, a PASOE for web, the web transport. There it says web transport. So not very helpful, but then you got to go learn what all the lines are. There's, I don't know, 70 odd different metrics in here. So the second thing I did after I did this was I decided I needed to be able to break it out. So I went and broke it out by different transport requests: web, REST, and APSV. And you'll notice these are 3 examples of the top one's web, the middle one's REST, and the bottom one's APSV. You'll notice the data's not the same. I had this great view or thought that you know, I'm polling PASOE for performance data. It should be the same across the board for no matter what type of transport I'm using. That's just not the case. So now you have to go create 3 times that to be able to figure out where to go parse the data out of and what data to get. Even with the web transport, and the web transport by far is the one we want to be at and where we want to go. Our REST environment is moving to web probably over the next 6 to 12 months. APSV, if you're not familiar with it, it is really listed as the replacement for Classic App Server. It runs the closest to Classic App Server from our experience and what we learned. So anyway, so different types of polling data broken down into each one of these sets of data. I need a drink. Everybody with me so far? Doing good? Okay. So still, when I look at this, even with that web request, one of the challenges that we had with that was there are 4 or 5 different counts of errors in that data. So how do I go figure out what my errors are, what my errors look like, or where the errors are? So I'll come back to that in a second. I'm sorry, I'm skipping ahead of myself. Remember we talked about the agents earlier, and in that iceberg view, I could show you, you could see the agents. One of the things that we quickly learned was from an agent standpoint, I need to be able to see how many total agents do I have, how many are current, how many are idle, and how many are active. So my total agent count doesn't count in here because that's just calculated, and you can go to OE properties and go out and calculate how many multi-session agents you're going to have. But this gives me an easy view of how many agents are current. That means they've started up and they've ran. They may not have gone away yet, but they've started up and they've ran, so they're current. How many of them are idle, and then how many of them are actively doing work? So the reason we did this was so that I could quickly go see, okay, they're calling me and telling me that I have a PASOE performance problem, or that they're getting 500 errors, but only part of the time. Well, I got to go understand and figure out where's the problem happening. Which of my 4 servers? Do I go individually go to each of the 4 servers and look it up? Do I go try and figure out all those details? So this is what this tells me. It gives me an idea of, hey, now I can go look at all my servers. The DB is the first one, and then my 4 instances, and go, hey, where do I see the problem? And it's like, okay, so it looks like on LX02, my PAS Liquid 1 has 11 active servers. So maybe I have a long transaction, or maybe somebody's running something that they shouldn't, or maybe there's a lock wait time out there that they're just pounding the system for specific requests. At least I have a little bit better view of this to be able to understand all of these details. So this is what parsing that data and gives us the ability to be able to go debug and tune the system faster and faster from that perspective. So this is great from what's happening right now standpoint, but I need to understand what's happened over the last hour or the last 2 hours. So we wrote an additional script that went out and parsed the data, and this shows me throughout the day, again, every 5 minutes, this one goes for the last effectively 2 hours. How many are current and how many are busy? This one doesn't show you that, but one of the other things that it shows that this will show you is if I have a spike of the current, and my typical current is 10 to 12 that are currently active, that are current out there, and then my active are generally in the range you're seeing, 5 to 7 at the time that I go do a poll. But if my current jumps to 25 or 30 or 55, then I know that something spiked in that time frame, and I can then go back to the logs and figure out in the time frame what really happened during that time frame. Was there a request that that they made that was taking too long? Did we have, part of the way our application is designed is we have web bots who take in APIs, take requests from externally, and make those requests. You know, is there a web bot that's gone rogue and is just doing thousands of requests? So we can see that from the PASOE side, because it all flows down into PASOE. So if there's something at the web bot or the application layer outside of PASOE, outside of Progress, you know, it's a Java-based application, or part of it is, we have the ability, it affects us as well. It can affect us as well. So that's the type of view that you can get from that. So why did we decide to roll our own? When we started, we looked at the Progress Health Check tool that's built into PASOE. And this was early on 11.7, so I have not looked at it since then. Or not early on, but in 11.7. I haven't looked at it since then, but I looked at the health check, we enabled it, we ran it, and I struggled to make head or tails of it. You know, and the value it returned was between a 0 and 1. It's like, okay, so that tells me if it's up or it's down. Well, I need to know more details of that. And at what level do I need to go parse that? Do any of you use the health check today that's built into Progress? I'd love to talk to you and see what your experience with is with it, whether it's better or worse. So there was very little documentation that we could find on it. That's part of the challenge as well. So how do I trend and alert on data? I told you I output it to a file, and then that file is consumed by Sumo as well as other scripts that we work with. So we chose to do that because we knew we would have to integrate with a third-party tool. We knew we would have to go work with that. And we looked at OE management. We use OE management for monitoring the databases and whether they're up and down in some performance metrics, not much from a database performance metric standpoint. And it can basically tell us if PASOE is up or down. Well, we could figure that out pretty quickly. The business challenge, as I said, was, again, the corporate integration is what we had to deal with from that perspective. From a monitoring tools challenge, we looked at the health check. We looked at Iceberg, obviously. We use a part of Iceberg. We looked at ProTop, obviously ProTop RT. We're still working on ProTop, the browser-based solution, the portal. We want that, we need that, but we haven't gotten there yet. So we're definitely working on it. So that's kind of why we decided to use our own. We didn't have much PASOE experience in-house, so we had to go learn ourselves. And the easiest way for us that we felt to learn ourselves was to dig in and learn the actual details of how it ran. And that's how I learned how the database worked, and that's how I learned how PASOE works, is to go in and look at what's really happening. When I make a web request, what's really happening under the covers? Because there's lots of different layers inside of PASOE. There's the Impro APSVs layer, there's the Tomcat layer, there's layers below the Impro APSVs. So it's understanding all those details that helps you understand how and why we should go do that. So hopefully you have a little bit better understanding of why we chose to do that and why we went the path that we went. Some additional examples. We also realized that there was stuff that you could get from Iceberg that it was hard to get elsewhere, and Iceberg just presented in a really nice methodology, nice way. So this is an example of one of our scripts that shows us a lot of this top details from Iceberg. Although you can get some of this elsewhere. It tells me how many apps I have running, so I can go up here and look at this. But I can also look at my environmental details. You know, if I need to know, if I figure out that one's failing, now I know what ports specifically I need to go look at, what version of Progress I'm running. At one point in time, we were running 11.7 and 12.2, so that was important for us to understand from an interface standpoint, the configuration for it, whether it's set up, and how many threads are running. Again, those threads, if we see those thread counts go way up, that's an issue, that's a flag that we have a challenge from a performance standpoint in terms of running that. So that's an example of the PASOE status script. Remember earlier I talked about as you parse the data for web requests, there's like 4 or 5, or there are, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 different error counts. So if my total error count's high, that's one of my health checks, is if my total errors is above a certain number, I know I have a problem. Well, I quickly realized that tells me that I have a problem, but I don't know where it's at. So I went out and parsed out just the error metrics, and then I could go out and say, oh, okay, I'm getting put error messages out the wazoo, but I'm not getting any error messages anywhere else. So that tells me that my put requests, which in our environment, a put request and a post request, one is a read-write and one is a request only. So that helps me understand, drill down into that. So the other place where this shows up is Tomcat errors. That first column is Tomcat errors. Go try and figure out what that really means. There's no documentation on it that I could find in terms from the progress side, in terms of when we get a Tomcat error, is it just the 500 error? Because then I said, oh, okay, I'm getting 3 Tomcat errors in this sample. I should be able to go to the log file and find an error that says it's a Tomcat error. I couldn't find that. So I couldn't find it. So anyway, so that's part of the challenge that we faced as well, especially when it comes to errors, is getting the details out of progress to understand where it's at. And for some of these columns, we still don't know what the details are. You know, we get errors like the Tomcat errors. You can see I typically get Tomcat errors throughout every one, but I don't know what those Tomcat errors are. It may just be a bad URL request at the very, very highest level, but Tomcat's not logging it for me. So just be aware of that. Request count metrics. One of the other challenges we had is the request count metrics are cumulative. So from sample to sample, they will always grow. Now you can go reset those metrics. There's an API to reset the metrics counts. We've chosen not to do that yet. So what we do is when we gather the sample data, we parse out and take an individual sample. We get the last 2 samples and take the delta between them. So these are delta counts. But you can also see across this, you know, I have GET requests, connection requests, and you can see I have put requests and delete requests. So anyway, not all the data is there, but this is pretty typical of what you're going to see when you're looking at the samples and the different types of data. So a little bit different. But that was the other thing that we really pretty quickly realized, that we need to parse out this type of data to be able to make value out of the processing. So kind of to summarize, monitoring obviously is critical. For you to be successful with PASOE, you need to have some visibility into it. You can't just trust that I'm going to start it up and it will just run. That's been our experience, is that it will just run until you get your third user in. And for us is about 15 milliseconds. You know, I told you we restarted every night. During our night processing for production, it happens at 2:30 in the morning. At about 2:44, 2:45, we come up, and there are multiple people trying to get into the application and run requests at 2:44 and 2:45. So we see logins immediately. So that's a challenge. So, and understanding how it performs. Obviously, we chose to roll our own for a lot of this stuff because we didn't have a choice at the time. We had to go build tools. We had to understand how it worked. Before this, our architecture was had a sonic element into it and ran classic app server. So requests would come in, they'd be put into the sonic queue, and then we had SMQ processes, basically 4GL processes, that read that queue, parsed the request, put it back out on a queue, and it was picked up on the other side. We since have architected away from that, replaced that with PASOE. But we had, I don't know, 8 or 10 years of sonic experience, of tuning sonic and understanding the pitfalls of those sonic clients that we had to reproduce in PASOE within 6 months to a year. So we had to understand in details the architecture of how that worked to be able to get to that point. But since that point, Sonic's gone. We replaced our outbound messaging with IBM MQ using the ActiveMQ, the Progress ActiveMQ adapter. If you want to talk about that, I'm happy to talk about that at a different time. So you can roll your own. That's why we chose to do ours. You can use tools. There are absolutely tools out there. ProTop can do it. Open-Edge Management does a little bit. MDBA, I didn't show any of that. They do it some. Those are really the three big sets of tools that I can tell you from a commercial standpoint that are available. Now there may be other things that are available out there for you to access it and work with it, but that's what we know about. I told you all those scripts that I talked about, all the polling scripts that we have, all the health check scripts, and they're not for the faint of heart, and I take blame because I wrote them. The health check script is not easy to make it through, but it does what it needs to do, and architecturally it's pretty straightforward. But it at least give you a start in terms of some of the details, and that'll be posted. From a wish list, I always like to have a wish list. I wish that the documentation was a little bit more detailed in terms of polling and details and how the tool works, how the internals of it work. There is a really good white paper that Progress published on tuning PASOE. I've read it a couple of times. I'm still trying to figure out how that really works. Actually, that's an important thing. Actually, I don't remember whether it's on my list or not. I'll talk about that in a minute. So that's probably the biggest single thing that I wish for. The other gotcha that we ran into is, with Classic App Server, at least in our environment with Classic App Server, if the database goes down, does the app server go down? Classic, yes, it usually does, right? With PASOE, when the database goes down, it's happy. It keeps running. It stays up. Status looks like it's fine until you make a request. And then you start getting errors in the logs, but PASOE stays up and running. And that's probably one of the biggest challenges that we've had, is that they go, okay, the database went down in our test environment. Why is PASOE still showing green? It's like, well, that's the architecture. That's the way it's designed and set up. And we talked to Progress about it, and effectively what you have to do is to do the if connected, if not connected in the methodology inside the PASOE requests. Well, that's all good and fine when I'm running in a Sports 2000 demo environment, but when I'm running 3-4 million requests through PASOE today, I can't afford to do that check every single request. So I wish that there was a way that I could say, if I lose database connection, shut down PASOE. Or refresh my web handlers with PASOE. That would be a nice thing to be able to do. So Some additional things to think about. I mentioned that round trip check. That was really nice for us to have that DB performance. And it's not just a find first customer. It's got to be a query that's a reasonable amount of query. I think we run a query against a table that we know about, and it returns it goes and queries the first 30,000 records. And once that gets run once, it's in memory, yes, but at least it's a reasonable query to give us data. So that's really helped us a lot in understanding it. Things change. It's constantly changing. PASOE will stay the same, and it won't work on day 2 the way it worked on day 1. So understanding that change, you just got to be prepared to plan for it. And you have to have the scalability to be able to handle how big it grows in terms of how it scales up and how it gets more uses more and uses less. One of the things that we found in 12.2 is that our current connections, or our current clients, multi-session agents, goes up, and it never trails off. It never disconnects those agents, those multi-session agents. And I've read that there's a bug out there on this, and it's fixed in 12.5, 12.6, something like that. Maybe when we get to 12.8, it'll get better for us. It's not the end of the world, because we can look at active clients, active connections, and that's what's really critical to us. And we're on 12.2. Again, we started at 11.7. I'm glad that for the second application, our much, much larger application, we started with 12.2. I don't know if 12.8 is better than 12.2. If anybody has experience from 12.2 to 12.8, I'd love to hear that, because we are going to go to 12.8 at the end of next year. So that's part of our migration plan. Historically, the company that we support has been very, very, very conservative, and they only move whenever they absolutely have to. We have changed that methodology, and we've decided that we are going to stay as current as we can within reason. So since 12.2 is extended for another 5 years, we're going to stay on 12.2 until we can get to 12.8. And there's another challenge that comes into play with that. And there's a tidbit, if you come to my Keeping Local, we'll talk about AWS 2023 versus Amazon Linux 2 and that whole migration environment. So, example scripts are going to be available to you. There's a list of them that I have: status, show, that's all of them. And with that, I'm about 2 minutes over. I'll open it up for questions. I went through a lot of details, talked about a lot of different things. Any questions? Yes, in the back. Okay, the question was, have we also looked into OpenEdge Command Center? Very good question. Thank you. I owe you a $5 bill or money. We did look at OpenEdge Command Center early on, because at one point in time, in terms of trying to read the tea leaves, we saw that OpenEdge management was maybe going away in 12.2. And we're like, well, we need a replacement for that. So we looked at OECC, and through partial challenges within my organization and partial challenges within another organization that owns OECC, I could not install it and configure it. Now, from my company's standpoint, from our challenge, you have to have a MongoDB underneath OE Command Center. There is no discussion there. Well, I have a DBA team that's a MongoDBA focused team, Mongo focused team. So they had very stringent requirements for what type of Mongo database we could have. Those requirements didn't meet the OECC requirements. OECC was behind, and they would not install and configure an older version. So that's kind of what killed part of it. The other big reason I was looking at OECC was because of OpenTelemetry. Because I wanted to be able to go use OpenTelemetry to get that data. Because one of the other tools that we use, and I totally just forgot the name of it, New Relic. Well, we were using New Relic. We looked at New Relic as a solution because it was in-house. I can't, there was the other one. No, Dynatrace. So our other tool that we had was Dynatrace. That's a corporate standard where you move into Dynatrace for a lot of stuff. They have an OpenTelemetry API. So I'm like, hey, I could just go run OpenTelemetry, take all that data and move it into Dynatrace, and all my scripting that I just spent an hour talking about goes out the window. No, because I have to have OECC running to be able to do OpenTelemetry. So I couldn't do that. So I could not, so that was my challenge with getting OECC up and running. I've talked to Progress Product Management, it is the replacement for OE management eventually. And I'm like, well, if you're gonna replace it, I need all the functionality that I have in OEM in OECC today, because I rely on OEM to alert. From a performance metrics standpoint, OEM has 220 plus metrics. I was the product manager for Open Edge Management, so you can blame me for that. But it's got a lot of metrics from VSTs and everything. OECC had 22, something like that, at the time that we were looking at it. So there was no comparison between the two from that perspective as a replacement tool. So, thank you. I'm curious, have you tried it or not? Okay. So I know that also that they're doing more PASOE work within it. So I'd be curious what PASOE looks like from that perspective. Other questions? Nothing? Yes. Yes, yes. So the question is, can I speak to how our clients connect to the PASOE service? And so understanding the PASOE is an app server, right? It's effectively, I like to call it a threadless client, or a headless client. So we make web requests, REST requests into it for everything. From a type of client standpoint, we are, in terms of physical counts of clients, we have approximately 4,500 users. Maybe 2,000 of those are Chewy clients. We run a Chewy application. You know, it's the fastest to do mortgage work. That's just the reality. The rest of them are third-party requests like Salesforce. There's other types of ones. There's an internal company called Motor. So but those are all Java-based apps. So all those requests come in through that, and that's the architecture of our connectivity and requests coming in. So probably, even though 40% of our clients, from a progress standpoint, are GUI or Chewy clients, probably 70 or 80% of our requests that come in are through that web bot protocol. So it's all, and to us, that's kind of frustrating sometimes because it's a big black box. You know, we just see requests coming in. And it's like, well, who made this request? You know, and we can discern some of that, but it's not all of it. Our security from that perspective is a bit of an opportunity for improvement. Good. I think we're out of time. Thank you very much. I hope you found it useful. And again, I'm here all week, so I'd love to talk to you guys about what your experiences are, because that's the best way that we learn and we get better is by learning from each other. Thank you.